concepts for SQL tables. We know table is the most fundamental concept in SQL. So there are many concepts related to table. So today, let us learn those basic concepts. Yeah. C.1, create a table. We saw example. Yeah. So in our university example, we created 5 tables. All right. Let me just go through some basic requirements for a table creation. Command, create table, your table name, and after that, you need to address a lot of information. So we will talk about those things one by one. Yeah. Specify. So what kind of information you need to specify? Yeah. Here, ... So we need to specify ... This part. Yeah. All right. A new relation by giving a name. Yeah, that's this part. Relation. Table name. Table name. Relation. Yeah. All right. Yeah. Then attributes. The format, you need to provide attribute name first. Okay. So then data type after that. Then you may need to provide some constraints. Yeah, depends on your needs. Yeah. Today we will look at some basic constraints. Yeah. Oh, to right. Make it easier for you to view. Yes. Okay. Yeah. All right. Then constraints. Yeah. Many different constraints. Some constraints could be very complicated. All right. The first one, key. You may declare a column or a field as a key. But for a key, you need to have a key property. That's the uniqueness property. The values for that column must be unique. Then you can declare it as a key field. Some of the columns, they allow duplicate values. Yeah. So that's, very common. Yeah. Those columns you cannot declare as key field. Yeah. So here you may wonder, so why we care about key or not, right? Key or not. Some of the fields can be declared as key fields, but some of the fields cannot be declared as the key fields, right? So what's the difference between key fields and the non-key fields, right? Yeah. Key field, unique values. Can you find the situation that we need? The unique value property can help us a lot. Can you imagine some important situation where unique values really help us for some important feature? Search. Think about it. Yeah. Search is very important. When you have unique keys, unique values, yeah, key field. When you do search, you can apply binary search, right? Yeah, quickly, yeah? Because all values are different. Yeah. They are ordered, yeah. So you can sort them based on some order. Then the binary search, pretty easy. If you allow duplicate keys, although you can also apply binary search, but still you need to do a lot of work. For non-key field, although you can do, yeah, because we have to deal with those non-key fields, yeah, but you need to do more work, yeah, some more work for duplicate values, yeah. All right. Key uniqueness. That is the constraint you apply on a particular field. Yeah. All right. Entity integrity. Entity integrity. Yeah. All right. So what its meaning? Yeah. No primary key value can be null. So here we're talking about primary key. All right. Okay. So key, primary key. So they are different. Yeah. Later we will see those non-primary key, but also keys, we call them secondary key. Primary key, secondary key. So primary key concept. Yeah. We will have more discussion about primary key concept. No primary key value can be null. Yeah. So that is one constraint. Yeah. One hidden constraint. The hidden constraint, you do not need to declare it. You do not need to say anything. Yeah. DBMS assumes that the primary key cannot take the null value. Okay. Even if without not null constraint, right? Yeah, because that's the hidden one. Yeah. You do not need, yeah. So here, later we will learn this not null constraint. Yeah. You can apply not null constraint on a particular field. You do not allow null value. Yeah. But for primary key, you do not allow null value automatically. And you do not need to put that constraint. Yeah. 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 All right. So that's the entity integrity. Yeah. Referential integrity. That's the foreign key. Referential. Yeah. In the current table, you have a field. This field pretty special in this table because it refers to another key in a different table. Foreign key, referential integrity. That kind of relationship, the DBMS needs to maintain referential integrity. Okay, yeah, yeah. Later we will have a lot of discussion about foreign key because it's very complicated for foreign key. Yeah. All right. Alternate way to add constraints. So here we can see, here that's the way we see here, direct way, alternate way. Direct way, when you declare, when you describe a table, you add a constraint at the same time when you define a table. But you don't have to, you have a second chance to add constraints. Yeah. That's this alternative way to add constraint. After you complete the table definition, later you have second chance to add constraints. Yeah. That is, after the table is created, use alter table command. So there is a special command called alter table. After that, you specify in what way to alter that table. But here, the important thing is after table is created, you can do it in this way. Yeah. Sometimes this way is important. First, it's convenient. Yeah. Because when you define a table, you do not have to cover everything at the same time, because later you can use this alternative way to modify mainly the constraint part. Yeah, constraint part. Yeah, yeah. So, yeah, but in that way, but you need to think about when you create a table in a database, you also need to think about, have that picture in your mind. You need to make the table maintenance as easy as possible, right? Table maintenance, that's also an important issue, right? So think about if you spread this all table command, many different places, is it easy to maintain your table, right? Yeah, because after you define the table, you have many other different places spread out everywhere, then your maintenance could be very hard. So you also need to think about that. You have the flexibility, you have that power, the alt table gives you extra power to control the table, to modify the table. After you enjoy the power, but the maintenance part will be harder. So you need to factor in that part. Okay, all right, Next, base relations and the virtual relations. We learned this concept, virtual table, before, okay? But here, let us, do some comparison. All right, base relations or base tables. Okay, the relations are declared through create table statement. Just our regular tables, physical, regular tables. Okay, the relation and its tuples. So this word, tuple, the row. The row, each row, it contains multiple fields. And the order of those fields is important. Later we will discuss about that. In our next topic, we will look at the ordering property discussion more. All right, all right. So the relation and its tuples are actually created and stored as a file. So this file, I mentioned before, each table, there is a physical file on the hard disk created corresponding to that physical table. So as a file by the DBMS. All right. Virtual relations or views. So last time we called this views. How to create it? Virtual relations are created through the create view statement. So you can see we just replace table by view. They have a similar structure. Table, view, the structure pretty much, the same. But one physical, one virtual. That's the main difference. One physical, another virtual. Main difference. Last time I spent a lot of time explaining why we need the virtual tables, right? So a lot of reasons we may need the virtual tables. It may or may not correspond to an actual physical file. Usually, we do not need to create physical files for virtual tables. That's the reason, part of the reason we want to save our storage space. So part of the reason we use virtual tables, but sometimes some of the views could be very critical for certain business. That could happen, critical. Okay, so important. So then we are willing to use some extra storage space to store that part of critical data, view, physical files. So that's the permanent storage, right? Because after you make that view, physical file, that's the permanent storage. Unless you modify it. If you do not modify it, so permanent storage. Okay, But if you do not make a physical file, that could change because the data in a view comes from other tables, right? From other tables. When you modify any piece in other related tables, you automatically modify your view data in your view. Okay, so that's not permanent storage, right? And that's not permanent storage. Yeah. All right. Okay. Yeah. Contain the derived data. Another property for the views, derived data, not original data, derived data. Okay. Yeah. So. Yeah. All right. Yeah. Later at some time, I will show you some view examples. Yeah, pretty straightforward. Yeah. And starting from now, this point, yeah, because for this class, we will have two databases, university database and a company database. And a company. For this class. Yeah. University, I use that database to give you our first 3 case study examples, case study 1 to 3, yeah, to prepare you for our programming project number 1. Yeah. So this weekend I will post description, project number 1 description. Yeah. You start with our university example, case study example, then you modify, you add several new features. Okay. After that, then we won't use the university table. After that, we will use the company database for the remaining of the semester. Okay, yeah. So all our discussions, because we need to use a concrete database to give you some specific concrete view. Yeah. You can see, you know, how to get those concepts. Okay, yeah. You want to see something explicitly. So we use the company database to cover the remaining concepts. All right. All right. C.2, ordering property. So now, we discussed this basic property, ordered or not for attributes and tuples. Yeah. So the ordering properties for these 2 concepts are different. Attributes and tuples, columns and rows, they are different. Ordering property. All right. Let's look at the attributes or columns. When we talk about attributes or columns, yeah. Okay, yeah. The attributes in a base table are considered to be ordered. Yeah. Okay. If you change the order, that will be different set or different, yeah, sequence, right? So here the word is important in the sequence. Here we use the word sequence. We know elements in a sequence, the order, its order matters. Sequence, we consider the orders. Order information is important in a sequence. Okay, yeah. So the attributes in a table for a base table, so we treat as ordered and as a sequence. Yeah. All right, yeah. They are specified by create table statement. Create table, when you specify attributes, that order is important. Okay, that order is important. Yeah. All right. But for tuples, right? For tuples or rows, then it's different. The ordering property It's quite different, completely different. Yeah. So let's look at how it is different. The tuples are not considered to be ordered within a relation. Can you imagine that? Yeah, relation, that's a table, okay? Table, all right. So here we have a table, okay? Yeah. So we have a set of rows, tuples, rows, all right? Yeah, okay. Then think about when you change those rows within the table, we treat the result as the same table. We do not treat. You get a different table. Okay, so yeah, because based on our, the property description, the order is not important for tuples. Yeah, within a relation. Okay, yeah, you won't get a different relation. Okay, yeah, tables, that's the same table. You just change the orders. Okay, change the order of the tuples. Yeah. But for attributes, that's different. You change the order of attributes, you will get different sequence. Yeah, here let's just call a sequence. Okay, we cannot call we don't want to call tuple, right? Yeah, because that will be different concept. So we call it sequence. Okay, yeah. All right, understanding. Yeah. Elements inside a tuple are ordered. Yeah. So based on our, understanding. Yeah. Later we will look at this furthermore. Yeah. Another level, deeper. Yeah. Elements inside a tuple are ordered. Inside tuple, okay? Yep, element, that's the attributes. Attributes inside tuple, ordered, okay? All right. When we treat the tuples as elements, now we treat tuple as elements. One tuple as one element. In a table, one row as one element, okay? But in that way, it's unordered. Unordered. Okay, you get the same table if you change in different orders. Okay, all right. We view a relation as a set of tuples. Here, the wording is important. Wording, important. Look at the word we use here, set. The word we use here, set. The word we use in this place, sequence. Set, sequence, set, sequence. The main difference between set and a sequence, that's the order property. Order property. Okay, yeah. In a set, the order doesn't matter. Doesn't matter. You change the order of the elements, you get the same set. In a sequence, the order matters. When you change the order of the elements, you will get a different sequence. Okay, yeah, so when you use the word set or sequence, the meaning is quite different. Yeah. All right. Next, we consider another two concepts, two closely related concepts, set and multi-set, these two concepts. Yeah. Because later, when we do queries, sometimes when you see different behaviors, you need to use the understanding of these concepts to get a reasonable explanation. Yeah. All right, so set and a multi-set. We just discussed the set. So you know the main property of the set. All right. And we focus on the order property, but set has another property. Yeah. Yeah. In math, Yeah. In math, you learn the set concept, right? Discrete math. Math 3000, you learn the discrete. In that course, you learn the definition of set. Yeah. Set has two basic properties. Okay. Yeah. All right. So here I just review a little bit. Okay. Set two basic properties. First, unordered. The elements are unordered. The first property. So we discussed in the previous slide. Second, another property, uniqueness. That's the second property. Yeah. Given a set of elements, if we can call it a set in the mathematical meaning, mathematical definition, then this object must have these two properties. The elements are unordered and the elements are unique. Then you can call it a valid set. Okay. All right. So here we use the same concept for the set. All right. Then there is some difference between SQL and the formal relational model. Yes. Why we talk about this? Formal, what is the formal relational model? Yeah. I mentioned, something related before about research project in universities, some organizations, right? Yeah. So there is some theoretical research for relational database. Yeah. In that research project, those researchers, they use the formal relational model to describe, to build DBMS. Okay, yeah. So they start with that formal relational model. Okay, so they need to define many concepts rigorously in their model. Okay, yeah. But here we talk about some difference. Yeah, because the SQL currently it already becomes an industry standard. Industry standard, right? Yeah. So it is mainly used in the business world. SQL. SQL is used mainly in the business world. All right. Yeah. So you can see in these two different places, one is academia, another is the business world. These two places quite different. All right. Yeah. So that caused the difference between the SQL and the formal relational model. Yeah. All right. Then, as a consequence, so we have the following discussion. SQL emphasizes the real-world applications. You need to solve real-world problems. When those companies, when they use SQL to manage their databases, they need to solve real-world problems. So it must be practical, okay? All the concepts, features, describe it in SQL must be practical, right? Yeah. But for the formal relational model in academia as a research project, those researchers, they may not treat that practical, 100%. They do not require, 100% practical, right? Yeah. So they will have their different priority for researchers. Yeah, they are not business people. Yeah, they're researchers. So they have their own preference. All right, that causes the difference. All right, yeah. So I will, describe the key difference. Yeah. The formal relational model emphasizes on a rigorous theory. Researchers, they like a rigorous theory, beautiful theory. Yeah. Must be rigorous first. Yeah. If there is some hole, they won't be happy, right? They need to fix, all the possible holes. Must be rigorous and must be beautiful, all right? Yeah. That could be their first priority. Yeah. Yeah. But they may sacrifice a little bit, So if they emphasize that, beauty of the structure, rigorous, that part, they may sacrifice some other places. Yeah. So it may not be practical. All right. Yeah. So you will see. Yeah. Views of tables. Yeah. Now, when we look at tables, how to treat table objects, then there are two different views. Here, the views, that's just our general views. It's the views you see here, not a virtual table meaning, okay? Not a virtual table meaning. The view you see here, just a general view meaning, okay? Yeah. So those, people from those two different world, areas, they have different views on table. Different views on tables. Okay. Yeah. So how different? Yeah. Let me describe the difference. Yeah. SQL allows a table to have two or more tuples. Yeah. Two or more. All right. Tuples that are identical in all their attribute values. That's the key. This property in SQL, it is important. In SQL, it is important. All right. So in SQL, a table should be a multiset. A table should be multiset, not a set. Multiset. What is a multiset? All right. Multiset, we remove uniqueness property from set. Because set will require uniqueness property. Okay. Multiset, we remove uniqueness property. Still unordered. Yeah. So yeah, if I write, the key property of the multiset, all right, I just put unordered property. Yeah. Still, we should have the unordered property, but we remove that uniqueness property. Okay. You are allowed to have duplicate elements in a multiset. Yeah. In that way, so in SQL, later, we will use this multiset understanding, all right? Yeah. Why SQL, the business world people, they prefer modify the original formal relational model requirement that a table must be a set, all right? So the business people modify it. The business people make that modification from set to multiset. Allow duplicate rows in a table. All right, yeah. In the formal relational model, a relation is required to be a set. Uniqueness, okay, element uniqueness. No tuple is allowed to be repeated in a relation, okay? Yeah, that's the, academia, researchers, they like the rigorous, requirement on this one, but not practical. This requirement is not practical. Why? Because the result is pretty simple. In real world applications, when you need to deal with real world problems, business problems you want to solve, many times your search result as a table that could contain multiple rows with exactly the same values. Yeah, in our company database, we will have that situation. All right, in our company database, yeah, we will have, yeah, for some of the queries, we will have that kind of results. Do you say those results not legal, right? For the academia researchers, you know, based on their rigorous requirement, they will say those are not tables. Those are illegal tables, all right? Then, you know, for business people, they feel, oh, we need that result. That result is useful, right? Yeah. And it happens frequently, all right? So then they have to make it practical, they have to make that modification. All right, yeah. So here I spend a lot of time to talk about the difference between set, multi-set. Yeah. So when you go to the business world, you need to use that multi-set understanding. Now, actually in this class, we will use that multi-set understanding. Okay, yeah, yeah. Don't worry, your table contains multiple rows with the same values. That's legal table. Okay, that's a legal table. Yeah, take it. Yeah, yeah. All right. Next topic, C.3, basic constraints. Here, let us discuss some simple basic constraints. Some of the constraints could be very complicated, but when we start, so let's look at some simplest constraints first. Yeah. All right. Define a primary key. Let us discuss this primary key. It is very important. Primary key in a table, primary key, yeah, very important. The properties, yeah. We need to have better understanding. Yeah. But before we have this discussion, I like to say another property related to a primary key in a table. It is optional, not required. Right? The table, the primary key in a table is optional, not required. Okay? Yeah. So a table, to be a legal table, it does not have to have a primary key. Okay? Yeah. It can still be a legal table. Yeah. Okay. All right. So it's optional. Yeah. But we know if a table has a primary key, it will be much easier to use. When you refer to the rows, tuples inside that table, it will be very convenient with a primary key. Yeah. Otherwise, it is not easy to refer to a particular row in a table. All right? Yeah. So it is useful, very useful, and it is desirable. We like to have a primary key. Yeah. But sometimes you may not be able to get it. Okay? You may not be able to get it. Okay? But you have to accept that possibility. Okay? All right. Yeah. Use the primary key clause. Here, how do we define a primary key? The first method, use the primary key clause to define a field as a primary key field. Okay, yeah, the clause. All right, yeah. How to use it? Yeah. All right. The primary key clause specifies one or more attributes. Yeah. Look at this part. This is the important part. One or more attributes. Okay, that make up the primary key of a relation, of a table. All right. Yeah. But for one case, it's easy to understand, right? Yeah. So one particular attribute is used as a primary key. Yeah, that is very easy to understand. But for more than one, multiple attributes as a combination, as a tuple, right? Yeah, we'll put together. Yeah, combine. Yeah, as a primary key. How to understand that part, right? Yeah, yeah, that is useful. Sometimes we need that. Yeah, so we will discuss about that situation a little more later. More than one attributes we can use as a primary key. All right. Yeah. How to, yeah. So if a primary key has a single attribute, that's easy. Single attribute, you want to make it a primary key. That's pretty straightforward. Okay. Yeah. The clause can follow the attribute directly. You just append that primary key, that keywords clause at the end of the, description line. Okay. Yeah. Yeah. So, yeah. Let's look at this simple example. Yeah. Here, this example we take from that company database. So I will give you that database next time. Yeah, so you can install it. Yeah, because later you need to play around. Yeah, when I show you examples, I use that database, company database. Okay, and all our homework questions, our test questions, we all use that company database. So that's important for this class. Yeah. We won't use university. Okay, university after our project one, we forget about it. Okay, we never use it anymore. We will use for the remaining of the class company database. Yeah. So this example comes from the company database. Yeah. All right. D number. Yeah. So in a table, yeah. In some tables, some table, there is a field called a D number. D number means department number. Okay, in a company, so the department, projects, employees, projects, department. Yeah, I mean those basic things, basic entities you can see in a typical company. Okay, now here, D number. Let's consider. Suppose we have a department table, right? Yeah, so we have a department table. In this department table, yeah, each department, you should have a department number, right? Yeah, you should have a department number. That number can be used as the primary key of the department table. Yeah. So how do we make department number, D number, as the primary key? Yeah, in this example, D number, int, data type, all right, primary key, constraint. Yeah, so you can see the order. The field name, D number, second data type, after that, constraint, primary key. No comma separate them, all right? Yeah, so you write one by one in that order. Yeah. So you declare a primary key as simple as this one. All right. Yeah. Another form of primary key clause after, yeah. So after, yeah. So after you declare all the fields, after you declare all the fields, yeah. All right, you can still add primary key clause. That's the meaning. Okay, so not immediately after a particular field. Yeah, after the field declaration line, you have a second chance to add this primary key clause. That's the meaning. All right, let's look at example here. single attribute primary key example. Yeah, for single attribute primary key, we can do in this way. Yeah, that is, all right, later, yeah, at the end, yeah, after all your attribute declarations, you can write this primary key clause. Primary key parenthesis, the attribute number inside parenthesis, okay, the number. So that's another way to declare a primary key. Yeah, second way, yeah. The second way, yeah, sometimes quite useful, okay, yeah, quite useful. Yeah. Some people like this way, yeah, primary key, all right, yeah. All right, another good thing about second way, yeah, for composite primary key, composite, more than one attributes are used as a primary key. Yeah. That's called composite primary key. Okay? Yeah. So in that situation, then we have to use this way. Okay? Yeah. The first way, yeah, inline way. Yeah, I can call it inline way. Yeah, because I didn't see the name, in the textbook. Yeah. Yeah. But based on our web technology terminology, yeah, so we call it inline way. All right, yeah, okay. Composite primary keys, yeah, we can declare in this way. Here, this example, primary key clause parenthesis, then you specify multiple attributes separated by commas. Yeah. Here we use this simple example, parenthesis ESSN, comma, department underscore name. All right, yeah. So what's that? Yeah, here, this example, we take it from that company database. Yeah. In that one, we have this special case, yeah, yeah. Because in one table, yeah, for example, as I remember, it's like a project table, yeah, because we need to create a table that store all the projects, okay, all the projects, right? Yeah. But you can consider, look at each employee can participate in multiple projects, right? Yeah, each employee can participate in multiple projects. Another direction, several employees are involved in one particular project. You look at that, right? So you want to store the employee information and the project information and the relationship between them, right? So that's something like a relationship table. Yeah, here, relationship table, relationship table. We talk about relationship between employees and department. And then, project, related project, possible project. Okay, all right. So then, if you just look at the ESSN employee, ESN means employee social security number. That won't be unique, okay? ESN's, that attribute, that column may not be unique because the same employee may appear multiple times for a project, right? Yeah. Department name also not unique. One department, they may have several projects, right? So each one not unique, okay? But the combination could be unique, all right? Yeah, composite. In this way, there is a reason we use composite primary key. Yeah. Because each individual attribute, not unique. You cannot use it as a primary key, right? In that situation, we may need to consider composite primary key. All right, yeah. So it will make our table structure a little more complicated, but we have to consider that situation. Okay, composite primary key situation. Yeah. All right, yeah. Use the alter table statement. Yeah. Later, after your table definition, you still have a chance to declare the primary key using alter table statement. Let's look at this example. Calls. Yeah, this is from the university database. Alter table name calls, add a primary key, the attribute calls underscore number. Yeah. So after table definition, you have a chance to add primary key. Okay, all right, yeah. So that's the primary. Then define key, secondary key. Yeah. So this is the secondary key. Yeah. All right. Use unique clause. How do you declare a column, a field as a key field? Yeah. Unique clause. Yeah. This time. The unique clause specifies alternate secondary keys. And one table, you can have multiple key fields. Multiple key fields. Okay, yeah. Yeah. All right. The unique clause can also be specified directly for a secondary key if the secondary key is a single attribute. Similar to the case for the primary key. Yeah. Single attribute, you just append it at the end of the declaration. Unique. Yeah. Unique. Yeah. So then that field becomes a key field. Yeah. All right. Example. Single attribute key. DName. Yeah. Here. Yeah. This example comes from the company table database. DName department name. Okay. Department name. Some place we call it DName. Yeah. Short DName. DName varchar 15 unique. That constraint, uniqueness constraint. Yeah. So then that's a key field. That's a key field. Yeah, but not primary key field. It's a key field. Okay, unique. Yeah. With this constraint, you can imagine when someone is trying to insert a new department with duplicate name, then the DBMS will complain. DBMS would complain because you have this uniqueness constraint. DBMS will enforce this constraint automatically. Okay. Otherwise, if you do not have this unique constraint, DBMS will allow it. Okay. Would allow it. That means you will have a second department with the same name. You don't like to have that, right? Another department that repeat a name of some previous department. So yeah, so you can see this constraint is useful. All right. Or add after, yeah, after you declare all the fields, you still, at the end of it, you have a chance to add uniqueness, unique constraint. Yeah. In this way, yeah. Unique parenthesis field name. Yeah. That's simple. Yeah. Similar to the way for primary key. Yeah. But here, uniqueness. Yeah. Unique. Yeah. All right. Composite key. Yeah. Also similar to the primary key, we may have composite key. Yeah. You can use the same logic. Unique parenthesis field 1, comma field 2. Yeah. You want to make this composite key value unique. Yeah. Yeah. So the DBMS will check, will enforce unique values, unique composite values automatically. Yeah. All right. Use the alter table statement. Yeah. After you finish the table definition, you have another chance to change your constraint using the alter table statement, like this one. Yeah. Alter table name, add a constraint. So this time you add a constraint. All right. Constraint, you have option to provide a constraint name. Yep. This constraint name is optional. Okay. Yeah. But if you do not provide a name for the constraint, later you do not have a chance to modify it because there is no name for the constraint. How do you refer to it? Right? You have no way to refer to reach that constraint. There is no name. You only have one chance to declare it. Okay. But if you give it a name later, yeah, for example, I want to change this constraint. I just use this name. I can make the change. I can drop it. Yeah. Because sometimes I don't need this constraint. Yeah. When the situation changes, I don't need this constraint anymore. I can remove this constraint. Yeah. So if you have this name, then you can do it. Otherwise, you have to find a different way to do it. Although you still can do it, right? Yeah, but it will be a little harder. Yeah. You need to, have the special privilege, go to the, database table structure and delete it. You can delete it. You select this item and then drop it. Then you create a new one. So you still, you have a chance to change it if you have the privilege to do that. All right. Yeah. Okay. All right. The last one, constraint not null and a default. Yeah. This constraint. Yeah. So not null. Yeah. Sometimes in last lecture, we spent a lot of time discuss the null value. Null value. All right. Yeah. And sometimes it is necessary to allow null value for some of the fields. Yeah. But sometimes you do not allow null value. So you use this not null constraint to tell DBS, for this particular field, I do not allow any tuple to have a null value for that particular field. All right, yeah. For example, the primary keys we just discussed, the primary key does not allow null value. Okay, yeah. So that's the default hidden constraint. Yeah. But for some other non-primary key fields, it is still possible you may need to have this constraint. Yeah. And a default value. Yeah. Default value. Sometimes if the value is not provided, then you may like it to take some special default value. Yeah. So you can specify it. Yeah. It's quite natural. So constraint not null when an attribute does not allow the null value. Yeah. So let's look at this example. Explicit way. Yeah. Explicit and implicit. Implicit, primary key, that's implicit, right? Primary key. But for other non-primary key field, we need to do it explicitly. Okay, yeah. Here, this example also from company database, Pinot, project number, yeah, Pinot, yeah, we use this short name, Pinot, yeah, INT, yeah, 10 digits, yeah, in 10 digit, up to 10 digit integer number, yeah, data type, unsigned, yeah, also data type, yeah, so unsigned integer number, yeah, then not null, yeah, that field, when the data is entered, DBS will check the value cannot be null. If it has the null value, DBS won't allow it to be inserted. Okay, yeah. So you have to fix it. Yeah. All right. Implicit. Yeah, that's what we just learned for the primary key. Implicit. You do not need to specify it. Yeah, it's redundant. Even if you specify it, no harm, but it's redundant, not necessary. All right. Yeah. Yeah. All right. Default value. That's pretty straightforward. Yeah. How to declare it? Yeah. By appending the clause default, then the value part. Value part, you can imagine the integer value and string value. Yeah. Okay. Yeah. All right. The default value is used in any new tuple if an explicit value is not provided for that attribute. Yeah, that could happen. Yeah, explicit value not provided. Okay. Yeah. Yeah. Then, if you have some suitable default value, then you should put there. Yeah. 0, for example, sometimes you like to make the integer. If it's not provided, you use the 0 value. That's the most commonly used default integer value, 0. Yeah. Then for string, empty string could be used as a default value. Yeah, things like that. Yeah. Okay. Yeah. If no default clause is specified, then there are some possibilities. No default clause is specified, yeah, then without not null constraint, yeah. If there is no not null constraint, then the null value is used as the default value. Yeah. Because you do not provide default value, and you do not say not null, then DBMS will put this null value there automatically. We know it's a warning, right? When you have a null value, it's like a warning. It is not a normal value. It is special value. When you encounter the null value, you need to do something, or at least you need to report to some higher level people. Need to take some action to fix this problem. Okay, null value, yeah. So it is placed there. With not null constraint, insertion failure. Yeah. You do not provide default value, but you put a not null constraint. Yeah, so null value cannot be taken. Yeah. But some user does not provide anything there for that field, then error, insertion error message, yeah. Some field, the value not provided, you will see some error message. in the DBMS, you will see that. Okay, so you need to fix that before you can make a successful insertion. Yeah. All right, so that's pretty much what we have today. So you can see before this basic knowledge, we spend a lot of time, part A, B, C, and next time part D, we pretty much complete this part. The reason is if you do not have all this kind of background knowledge, then when you do database queries, when you do SQL queries, you may have various questions here and there. Why I cannot do this? Why I cannot do that? Why violation here and a violation there, right? Yeah. So the background knowledge will help you. Yeah. When you do debugging, when you do SQL query debugging, yeah. So you need this kind of background knowledge, basic properties. Yeah. All right, so that's it. So let me stop right here, and we just at the end of the class, 8:10.